Hi everyone, welcome to today's GCSE Higher Revision video. There's 9 days to go to your GCSE Maths exam, and today we're going to go through the answers to yesterday's practice paper. So obviously yesterday I gave you a practice paper, and the video yesterday gave you hints in any of the questions that you may have needed hints on. But today we're going to go through the full solutions. So feel free to mark the paper, to go through it, and to see if you've got the questions right, and if you didn't, to listen to what advice and tips and tricks that I'm going to give you, but also what other videos on Corbettmaths might be useful for each of those as well. So today we're going to go through the answers to the practice paper. If you haven't tried the practice paper, it'd be a good idea before watching this video to look at yesterday's one, where I give you the practice paper and there's a link to the practice paper and so on. So I really hope you found this video useful. They're going through the answers, and I'll see you in a bit.
Okay, so let's have a look at question number 1. So question number 1a says simplify x squared minus 4x minus 32 over 5x squared minus 41x plus 8. So let's factorize the numerator and let's factorize the denominator. So in terms of the numerator, I'm going to put my bracket, and then also with my denominator, I'll put the brackets as well. So for the numerator, we've got x squared, so let's put an x at the front of our brackets. Now I want two numbers that multiply together to be minus 32 and add together to be minus 4. So I'm thinking minus 8 and plus 4, because 4 times minus 8 is minus 32, and minus 8 plus 4 is minus 4. So that's our numerator done. Now let's have a look at our denominator. So we've got 5x squared, so let's do 5x and x. We want two numbers that multiply together to be 8, and then whenever we expand our brackets, we get minus 41x. So I'm thinking that it's going to be two negatives, because with it being two negatives, a negative times a negative is a positive, and then that'll mean that whenever we expand our brackets, we can hopefully get a negative there. Now if we look at our numerator, we've got minus 8x here, so I'm going to try and minus 8 there as well, and let's see if that works. And because they multiply together to be 8, that's going to mean that'll have to be minus 1. And let's just check that. 5x times x is 5x squared. 5x times minus 8 would be minus 40, and then another x would be minus 41x, and then we've got our plus 8. So that's it. So we're factorized. Now let's cancel down. So that'll leave us with x plus 4 over 5x minus 1. And if you got that, well done. And let's have a look at our next question, part B. So we've been asked to express this as a single fraction, 9 over x minus 3, subtract 2 over x plus 1. So let's multiply both the numerator and denominator of this fraction by x plus 1. So that'll be 9 bracket x plus 1, close brackets, over, and then on the denominator we'd have our x minus 3 and then our x plus 1. So multiply both the numerator and denominator by x plus 1. We've then got our takeaway, and then we're going to multiply both the numerator and denominator here by x minus 3. So it'll be 2 bracket x minus 3 over, and instead of writing x plus 1, x minus 3, I'm going to put my x minus 3 first. I'm just going to turn them around to match the other fraction, so x minus 3, x plus 1. So we've multiplied both the numerator and denominator of this fraction by x minus 3. Okay, now let's write it as a single fraction. So we're going to do this, take away this, and then, take away that, and then on the denominator, it'd just be our x minus 3 and our x plus 1. So we've written it as a single fraction. Now we just need to simplify the numerator. So let's expand our brackets. 9 times x would be 9x, and 9 times 1 would be 9, so plus 9. And then we've got minus 2 times x is minus 2x, and then minus 2 times minus 3 would be plus 6. And then that's over our x minus 3 and our x plus 1. So we've expanded our brackets, and now let's simplify. We've got 9x take away 2x, that's 7x, that's 7x. We've got 9 plus 6, that's 15. And then our denominator would just stay the same as x minus 3 and x plus 1. And that's it. And that's our answer. 7x plus 15 over x minus 3, x plus 1. And if you got that, well done. Okay, let's look at our next question. Okay, so question number 2 is a histogram question, and we've got the histogram, and it's to do with cars travelling through a village. We want to find the percentage of cars that travel 30 miles per hour or less. So we want to find all the frequencies. So to find the frequency, we're going to multiply the frequency density by the collapse width. So for this first bar, its frequency density is 5. Its collapse width, how wide it is 30. 5 times 30 is equal to 150. So there's 150 cars in this bar. Our next bar, the collapse width is 10, and the frequency density is 6.246. So it's going to be 6.6 multiplied by 10, which is equal to 66. So there's 66 cars here. Next, we've then got our next bar. The collapse width is 20, and its frequency density is 3.246, so 3.6 multiplied by 20, and that's equal to 72. And finally, this bar, its frequency density is 0.2, 0.4, and its collapse width is 30, so 30 multiplied by 0.4 would be equal to 12. So there's 12 cars there. So we can now work out how many cars are all together. Let's add them all together. Let's do 150 plus 66 plus 72 plus 12. And that's equal to 300. And now we just need to write what percentage of the cars travelled 30 miles per hour or less. So that's this bar. So it's 150 out of the 300, because there's 300 cars, 150 of them, half of them travel that speed. So it's 150 out of 300, which is equal to 50%. So the percentage is 50%. And if you got that, well done. Okay, let's look at our next question, question number 3. So question number 3, part A, we've been asked to express h in terms of c. So we're told that h is proportional, directly proportional to the cube of c. So I've written that down. I've done that in the hints yesterday. Now let's get rid of our proportional symbol. So we've got h equals, and then we put in k multiplied by c cubed. So just replacing the proportional symbol with the constant of proportionality. Now we're told some information, let's substitute that in. So we've got 480 instead of h equals k multiplied by 2 cubed, and 2 cubed is 8, so we've got 480 equals k multiplied by 8, and now we just need to divide by 8 and we get the k is equal to 60. So k is equal to 60, so we then put that back into here, so we're going to get that h is equal to 60 multiplied by c cubed, or 60c cubed, just written it like so, and that's it. Okay, next, our next part. Part B asks us to find h whenever c is equal to 5. So that means that h is equal to 60 multiplied by c cubed. So we're going to substitute 5 in here. So we're going to get that h is equal to 60 multiplied by 5 cubed. And when we do that, we get that h is equal to 60 multiplied by 5 cubed is equal to 7,500. And that's it. So h is 7,500. Okay, next, part C. Part C says to find c whenever h is equal to 30,000. So remember our formula is h equals 60c cubed. So h equals 60c cubed. And h is equal to 30,000. So 30,000 equals 60 multiplied by c cubed. Let's divide both sides by 60. So if we divide 30,000 by 60, that's equal to 500. So we get 500 equals c cubed. Now we just need to cube root. So if we do the cube root of 500, the cube root of 500 is equal to 7.937, and so on. And let's just round it to 3 decimal places. So that'll be 7.937. And that's it. That's c to 3 decimal places. Okay, so let's have a look at question number 4. So question number 4 is an exact trig values. So the sine of 45 is equal to root 2 over 2. And the sine of 60 is equal to root 3 over 2. So plus root 3 over 2. And we've been asked to work out the exact value of this. So just to simplify it, so if we add this together, we've got the same denominator. So it'll just be root 2 plus root 3 over 2. And that's it. And if you got that, well done. Okay, question number 5. This is the exponential graph question. So we've got the y equals half to the power of x. So let's do an xy table, x and y. And let's let x equal minus 2, minus 1, 0, 1, 2. And this is a calculator question, so you can just type these into the calculator. A half squared is equal to a quarter. A half to the power of 1 is equal to a half. A half to the power of 0 would be equal to 1. A half to the power of negative 1 would be 2. And a half to the power of negative 2 would be 4. So we've got our points, now let's plot them. And that's it, that's our graph of y equals a half to the power of x. Okay, let's look at our next question. Okay, question number 6. Question number 6 is this area under the graph question. So we've got the speed time graph, and we need to estimate the distance travelled by the rocket. So that means we need to work out the area under the graph. And it says 4 strips of equal width, and because it's 16 seconds, if we do 16 divided by 4, that equals 4. So each of our strips is going to be 4 seconds wide. So let's draw each of the strips. So we've got 0, 0. The next one would be here. Then we've got a line there, and a line there. So we've got 1, 2, 3, 4 strips, and then we're going to turn them into a triangle, a trapezium, and a triangle. So in terms of a triangle, we'll join up 0, 0 to that point. We'll join up that point to that point. We'll join up that point to that point. And we'll join up that point to that point. And we're going to get the areas of those 4 shapes and then add them together. Now, let's actually, just before we carry on, let's write down our coordinates. We've got 0, 0, so that's 0, 0 there, 0, 0. That's the coordinate at that point. This point here is 4 across, and it goes up to in between. It's a halfway between this final square. So here, if we divide 2 by 5, that's equal to 0.4. So that's 8, 8.4, 8.8, 9.2, 9.6, and in between these would be 9.8, so that's 4, 9.8. And actually this one's got the same height, so that's 12, 9.8. This one's obviously 16, 0. And this point up here is 8 across, and it's a third little square up, so it's going to be 12.4, 12.8, 13.2. So that's 8, 13.2. Okay, so we've got our points. Now we just need to find the area of each one of these shapes. Okay, so let's start off with the triangle, triangle A. So in terms of A, we're going to do half the base times the height. Now, because it's a triangle, the base of the triangle is 4. The height of the triangle is 9.8. So let's do a half of 4 multiplied by 9.8. And when we work it out, we get an answer of 19.6. That's 19.6. Okay, next B. So B is a trapezium. So we're going to do a half bracket A plus B times H. So in terms of our A and B, let's turn our head sidewards and look at the lengths of the two parallel sides. They would be 9.8 and 13.2. And then the H, the distance between them, would be 4. So let's do that. So 9.8 and 13.2. So 9.8 plus 13.2. And we're multiplying that by 4, the distance between them. And when we do that, we get 9.8 plus 13.2, and then divided by 2, and then times by 4, that's equal to 46. So we've got the area of A and B. Now let's have a look at C. Now C's actually got the same area as B, because if you look at it, the length of the two parallel sides is the same, and the distance between them is the same, and D is actually the same as A. So actually that means that C would be equal to 46, and D would be equal to 19.6. So we've got the 4 areas. Now we just need to add them together. So 19.6 plus 19.6 plus 46 plus 46. And that's equal to 131.2 meters. So that's our estimate for the area under the graph. Now part B says, is our answer to N overestimate or underestimate? So let's have a look. Our triangle is actually below the real graph. Our trapezium is below the real graph. So is this trapezium, and so is this triangle. So that means our answer is an underestimate. It's actually below the actual real area under that graph. So our answer is an underestimate. And let's explain that. And I've just written down an underestimate as the actual graph is above our shapes. And that's it. Okay, let's look at our next question, question number 7. So question number 7 is an nth term question. So if we have a look at our sequence, they're going down by 3 each time. So let's write down minus 3, minus 6, minus 9, minus 12, and minus 15. Because it's going down by 3, we're writing down minus 3n, so minus 3n. So minus 3 times 1, minus 3 times 2, and so on. Now if we have a look at our sequence, to get from minus 3 to 14, we add 17. To get from minus 6 to 11, we add 17. So that means our nth term is going to be minus 3n plus 17. And that's it, minus 3n plus 17. And that's it, that's the nth term of our sequence. And part B says find the 50th term, so we just need to substitute 50 in here for n. So we're going to do minus 3 times 50 plus 17. Minus 3 times 50 is minus 150, plus 17 would be mean, we're going back up 17, so that would be minus 133. And that's it. Okay, let's look at question number 8. So question number 8 is on the inverse function. So we've got function f and function g, and we want to find the inverse of function f and the inverse of function g. So let's start off with a. So let's let this equal y. So y equals 8x plus 3. And we want to make x a subject. So we're going to take away 3 from both sides. So take away 3 and take away 3. So that'll give us y take away 3 equals 8x. And then divide by 8 and divide by 8. And we're going to get that y minus 3 over 8 is equal to x. And that means our inverse function is equal to x minus 3 over 8, just replacing that y with an x. So that's part A done. Part B, we've got y equals 2x minus 1. We want to make x a subject, so let's add 1 and add 1. So we're going to get y plus 1 equals 2x, and divide by 2 and divide by 2. And then we're going to have, on the left-hand side, y plus 1 over 2 equals, and on the right-hand side, x. So that means if we replace this y with an x, we're going to get that the inverse function of g is equal to x plus 1 over 2. And that's it. And if you got those, well done. Okay, let's look at our next question. Okay, question number 9 is completing the square. So we've got this quadratic. So we want to write it in the form of x plus a close bracket squared plus b. So let's open up our brackets and put x. So we have a look at the coefficient of x. It's a 4. So we're going to half this to be 2. So plus 2, close bracket squared. Then we take away this squared. Well, 2 squared is 4, so we're going to take away 4. And then we've got plus 7, so plus 7. So that means if we write it as x plus 2, close bracket squared, we've then got minus 4 plus 7. Minus 4 plus 7 is 3, so then be plus 3. So our answer would be x plus 2, close bracket squared, plus 3. Okay, our next question, question number 10. Okay, so let's have a look at our next question. So our next question says the mass of 3 meters cubed of tin is 21,840 kilograms, and we've been asked to work out the density of tin. So remember, the density is equal to mass divided by volume. So the mass is 21,840, and the volume is 3. So divided by 3, because we're given our units in kilograms per meter cubed. So if we do 21,840 divided by 3, that's equal to 7,280. So the density of tin is 7,280 kilograms per meter cubed. Okay, next we're then told the density of lead is 11,400 kilograms per meter cubed, and we've been asked to work out the difference in mass between 5 meters cubed of tin and 5 meters cubed of lead. Okay, let's start off with the tin. We know that each meter cubed is 7,280 kilograms, and we've got 5 meters cubed, so we just need to multiply this by 5. So if we take, remember that mass is equal to the density multiplied by the volume. So if we take the density, which is 7,280, and times it by 5, because it's 5 meters cubed, that'll tell us the mass of that tin, and that's equal to 36,400. So that's the weight of 5 meters cubed of tin. Now in terms of the lead, each meter cubed of lead weighs 11,400 kilograms, and we need to multiply by 5 because we've got 5 meters cubed of it, because remember the density times the volume is the mass. And when we do 11,400 multiplied by 5, that's equal to 57,000. So 57,000 kilograms. And now we've been asked to work out the difference. We just need to take these away. So if we take those away, so we take the 36,400 away from the 57,000, so 57,000 take away 36,400, that's equal to 20,600 kilograms, and that's it. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 11. So we're told a village is 20 miles from Belfast, and Connor drives to Belfast at 50 miles per hour, and Kelly drives at 60 miles per hour, and we've been asked to work out how much longer the journey takes Connor than Kelly, and to give our answer in minutes. Okay, so let's start off by working out how much time it takes them. So time is equal to the distance divided by the speed. So if we take the distance and divide it by the speed, we'll find out how long it takes them. So let's start off with Connor. If we take the distance, which is 20 miles, and we divide it by a speed, which is 50 miles per hour, that's equal to 0.4. So that's 0.4 hours. Now, we were dealing with minutes in this question, so if we multiply this by 60, we get that's equal to 24 minutes. So it takes him 24 minutes to drive to Belfast. So in terms of Kelly, we're going to take the distance, which is 20 miles, we'll divide it by the speed, which is 60 miles per hour. And 20 divided by 60 is equal to a third, or 0.3333, and so on, hours. And a third of an hour, if you multiply that by 60, you get that's equal to 20 minutes. So it takes Connor 24 minutes, and it takes Kelly 20 minutes. So the question says, how much longer does it take Connor? It takes him 4 minutes longer, and that's it. Okay, let's have a look at question number 12. So question number 12 is a vectors question, and we're told that AOB is a triangle, and that P is a point on AO, and Q is a point on OB. We're told the vector AB, so from A to B is 2A. So A to B is 2A. We're told that A to O, so A to O is 6B, so A to O is 6B, and the ratio AP to PO is 2 to 1. Now, if AO, the whole distance, is 6B, and this ratio is 2 to 1, that means that this part must be 4B, and this part must be 2, and this part must be 2B. If you share the 6 in the ratio 2 to 1, you'll get 4 to 2. Okay, and we've been asked to find the vector OB. So from O to B. Well, to get from O to B, I'm going to go from O to A, and then from A to B. So, and let's write that down. In terms of OA, well, going from O to A is going to be minus 6B, and then from A to B will be plus 2A. So let's write that down. OA is minus 6B, and AB is plus 2A. And that's it, that's our vector OB. It's minus 6B plus 2A, or you could write it the other way around, 2A minus 6B. Okay, then our next part, we're told that Q is the midpoint of OB, and we're told that B is the midpoint of AC. So that's the midpoint of that line, and that's the midpoint of that line. And we've been asked to show that PQC is a straight line. Okay, so to do that, what we need to do is we need to find the vector PQ, we need to find the vector QC, and then if we show they're parallel and they both pass through Q, then that means that PQC is a straight line. So we want to find the vector PQ. So we want to go from P to O and then from O to Q. Now we know from O to B is minus 6B plus 2A. So if we do half of that journey from O to Q, that's going to be minus 3B plus A. That would be from O to Q. So if we want to get from P to Q, we're going to go from P to O and then from O to Q. So let's do that. So it's going to be, so PO was equal to 2B, and then we add on OQ, and OQ is minus 3B plus A. So minus 3B, so minus 3B plus A. So 2B plus minus 3B, well, that's just going to be minus B, and then we've got plus A, so plus A. So the vector PQ is minus B plus A. Now let's find the vector QC, because if we can find that this is parallel to PQ and they both pass through Q, then there's a straight line. So let's find QC. So to find QC, I'm going to go from Q to B and from B to C. Now I know that B is the midpoint of this line, so that means that B to C would be 2A as well. And we know from Q to B is minus 3B plus A as well. So the vector QC will be QB plus BC. So let's write that down. So QB, if we go up, QB is equal to minus 3B plus A, so minus 3B plus A. And then from B to C is plus 2A, so plus 2A. And that means if we add these together, we're going to get minus 3B, and then plus 3A. And that's fantastic because QC is 3 times PQ. So QC is equal to 3 times PQ. that this vector is 3 times this vector. So that means that they're parallel, so therefore they're parallels. And they both pass through Q. So if the two lines are parallel and both pass through Q, that means that PQC is a straight line. So let's write that. And that's it. I've written down, since they're parallel and they both pass through Q, then PQC is a straight line. And that's it. Okay, let's look at our next question. Okay, so question number 13, we've got this quadratic graph, and we've got some points it passes through. It passes through -6, 0, and it passes through 0, -24. And then obviously we've got P0, which is this point here. And we've been asked to find the coordinates of the minimum point, which is this point here. So if we want to find the coordinates of this turning point, this point here, it'd be really handy if we actually knew the equation of the quadratic. So we want to find B and C. Now actually C, we can find that straight away, because we know that the y-intercept is equal to -24. Remember, to find the y-intercept, we let x equal 0. So the y-intercept is -24, so we're going to get -24 equals 0 squared plus b multiplied by 0 plus c. Now b times 0 is 0 and 0 squared is 0, so we get the -24 is equal to c. So that means that c is equal to -24. So we've got that y equals x squared, and then we've got -24 in the end. So if we worked out what c is equal to -24, that'd be really useful if we could work out what b is. So if we have a look at this graph, we've used where it crosses the y-axis. Now let's have a look at where it crosses the x-axis. It crosses the x-axis at -6 and p. And remember that whenever we want to sketch a quadratic, what we do is, remember, we find where it crosses the x-axis and y-axis, and find where it crosses the x-axis, we let y equal 0, so we let y equal 0, so 0 equals, and then remember we try and factorize it and then solve it and find the values for x. Now here we've got a solution is -6. That means one of the brackets must be x plus 6, because that means that whenever we solve this, then x would be equal to -6. So that's one of our brackets, and let's find the other bracket. Now in terms of the other bracket, we're going to have an x, because it's x squared is going to have an x. And we know whenever we expand this, we're going to get -24 in the end. So that must mean that this bracket is -4. And let's just check that. X times x is x squared. X times -4 will be -4x, and 6 times x will be 6x. If you add them together, you're going to get 2x. So that means the b is equal to 2, so plus 2x. And then 6 times -4 is equal to -24. And that's it. So we used the fact that we knew that across the x-axis at -6, that meant one of the brackets would have to be x plus 6. And then we also knew where across the y-axis was -24. So when we expanded our brackets, we know we have to get -24 in the end. So that means the other bracket has to be x minus 4. So that means it crosses the x-axis here at 4, because obviously you want it to be equal to 0. So that's fantastic. We now know where it crosses the x-axis. It crosses the x-axis at -6 and 4. Now in terms of finding the coordinates at this point, we could use two approaches at this point. We could use the fact that this parabola, this U-shaped graph, this parabola has got a line of symmetry. And you could find out if this is the turning point, it has to be in the middle of these 2 points. You can find the x-coordinate of this point, and then once you find the x-coordinate, you can substitute it in here to find the y-coordinate. I'm going to use that approach first. The other approach is just use completing the square at this point, and I'll use that approach second. So let's use the first approach to begin with. So this graph is a line of symmetry. So there's a line of symmetry like so down this graph. If we have a look here, we've got -6 and 4. So if we find the midpoint of -6 and 4, that'll be this x-coordinate of this point. So -6, to find the midpoint of 2 points, you add them together and half it. So -6 plus 4 is equal to -2, and half it would be -1. So that must mean that's -1. So that means this point has got the x-coordinate of -1. Okay, and let's just check that. If we've got -6 and -1, we're going to go 5 across, and then if we go across another 5, we get to here. So we've now got the x-coordinate. Let's substitute that into our equation, this part here, to get our y-coordinate. So y equals -1 squared plus 2 times -1, subtract 24. -1 squared, -1 times -1 is equal to 1. And then we've got plus 2 times -1, so it's going to be adding -2, because 2 times -1 is -2. And then we've got -24. So that means that y equals 1 plus -2, that's going to be 1 take away 2, which is -1. Take away 24, and -1 take away 24 would be -25. So that means that the y-coordinate of this point is -25. So that means the coordinates of this turning point are -1, -25, and that's it. And that's one approach. And another approach would be to use completing the square. So to use completing the square, we could use our equation y equals x squared plus 2x minus 24. Let's do completing the square on this. So y equals, and then in brackets, x, and then half this number. So it's going to be +1 squared, and then we're going to take away this number squared, so 1 squared is 1, so take away 1, take away 24, and then if we simplify this, we get y equals x plus 1 close bracket squared, and then we've got -1, take away 24, that's going to be -25. Okay, so we've done completing the square. Now what we're going to do is we're going to consider our transformations of graphs, because remember, whenever we've got a +1 inside the bracket, that moves the graph 1 square to the left, and then we've got a -25 outside, then that's going to move it down 25 squares. So if you have got the x squared parabola passing through the origin, you'd move 1 to the left and 25 down, so it'd move to -1, -25. So just go through it again. Because you've got minus 1 inside the brackets, that's f of x plus 1, so that moves the graph 1 square to the left. And then you've got subtract 25, so that's going to be f of x plus 1 close bracket, subtract 25, so it moves it down 25. So again, that would be minus 1 minus 25. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 14, and it's on geometric sequences. And part A, it says find the value of x. So we've got this geometric sequence. Now with a geometric sequence, if you divide a term by the previous term, that gives you what you're multiplying by each time. So if I do x divided by x plus 24, the second term divided by the first term, that's going to be what we're multiplying by. And then if we do the third term divided by the second term, the third term divided by the second term, those two would be equal to each other because this tells us what we're multiplying by to get from here to here, and this would tell us what we're multiplying to get from here to here, and they have to be the same. So that's an equation. Okay, so we want to solve this. So we could multiply both sides by x plus 24 and then multiply both sides by x. Another approach is to cross multiply. That's to multiply this numerator by that denominator, so that'll be x squared, and then to multiply that numerator by that denominator and put them equal to each other. So 3x minus 32 times by x plus 24. Okay, so we know that that times that is equal to that times that. Now we can just expand this and simplify. So we'd have x squared equals, and then expand the brackets, 3x squared plus 24 times 3x would be plus 72x. We've then got minus 32 times x would be minus 32x. And then we've got, lucky this is a calculator question, 24 times minus 32 is equal to minus 768. Now let's simplify this. So we've got x squared equals 3x squared. We've then got 72x take away 32x, that's going to be plus 40x, and then subtract 768. Now at this point, let's take away x squared from both sides. So if we take away x squared from both sides, we get 0 equals 2x squared plus 40x subtract 768. And now we want to divide by 2. So we get that 0 equals x squared plus 20x minus 384. Now at this point, you can either use the quadratic formula or to factorize it. I'm going to factorize it. If I factorize this, I get the x and x in the front of both brackets, and I get minus 12 in one bracket, and I get plus 32 in the other, because minus 12 times 32 is minus 384, and minus 12 plus 32 is 20. So that means that either x is equal to 12 or x is equal to minus 32. Now in this question, we're told x is positive, so it can't be equal to 32, so x equals 12. So find x. Now the question then says find the fifth term. So if x is equal to 12, that means that this would be equal to 36. This is equal to 12. This is equal to 3 times 12 is 36. Take away 34 is equal to 4. If we have a look here, we'll multiply by a third, multiply by a third, multiply by a third, or dividing by 3, and so on. So we'll multiply by a third each time. We've been asked to find the fifth term, so we need to multiply by a third again. So we've got 36, 12, 4. So we've multiplied by a third. We've multiplied by a third. If we multiply by a third again, we get that's equal to 4 thirds. If we multiply by a third again, that's equal to 4 ninths. So that means that the fifth term in the sequence is 4 ninths. So 4 ninths. Okay, let's have a look at our last question, question number 15. So question number 15 is on geometric proof, and actually if you watched the video 13 days to go, I've actually gone through this question already. I think the question was actually, it was turned sideways, but I've showed why x plus z is equal to y. And the approach we're going to use in this question is we're going to split it. So we're going to draw another parallel line through f, like so. I'm going to call that line AB, so that's the line AB. So we've now got the parallel lines, ED, AB, and GH, and we want to show that x plus z is equal to y. So what we're going to do is we're going to consider our alternate angles. So we can see that this angle is alternate to this angle. So these two angles are equal to each other. So that's x. We can see that this angle and this angle are both equal to z. So it means that x plus z is equal to y. And let's explain that. And that's it. So I've just written down that angle DEF equals angle EFA, and they both equal x because alternate angles are equal. And likewise, I've said that angle AFG and angle HGF are both equal to z because, again, alternate angles are equal. So therefore, x plus z is equal to y. And that's it.
And that's it. So in this video, we've gone through the solutions to the practice paper. I really hope you found this useful. Now, the main thing with the practice paper is to find out at this stage, with 9 days to go, where any of your weaknesses lay. So any particular questions or topics you still find tricky, and to try and do something about it to boost your confidence in those topics before the exam. Because if you can get all the topics secure, then you're going to do really, really well. You're going to get that top grade. Okay? So keep up the hard work. You're doing really well, and I'll see you tomorrow for the next video. Cheers. Bye.